Yeah.
Do you have time before the lecture to look at an issue we're having with our Git?
Okay, just give me here.
We're not sure what's happening, but when I try and do Git pull, it just like it spits out a whole bunch of errors.
Is it to your own repository or to the?
It's from it's the group repository from last time.
Make some changes already, right? So you can't do a clone again.
I don't have any changes.
Okay.
We were trying to edit our other group contract. I think you Clara was trying to edit it, and then for some reason it wasn't working for her, and then when I tried to, it was not working for me as well.
And then like it was just like you just like crawl back every inch of code to make sure all the things.
Is there any pending request or
Someone merged in something, but I don't think that was broken.
Probably require a little bit of debugging. Do a screenshot of the error if you can email to us. Yeah, we'll try to dig into it, why it's causing that. Yeah. Yeah.
Can I put it to the forum as well?
If you want, yeah.
Sorry, just a minor thing in OBS where the webcam's getting cut off, so I'm going to put that above. There we go. Yep, sweet, should be good now.
Okay.
Sweet, that was all.
Okay, thanks. Okay, we'll start shortly in 2 minutes. Okay, so it seems like the live stream is finally working. So, welcome to week 5. How are you all feeling? Are you satisfied with your iteration 1 submission and looking forward to the grades? Yes? Okay, that's good. We know that iteration 2 assessment has been released, and like I promised, we're going to discuss iteration 2 today. But before that, there are two important concepts that are central to iteration 2, which is persistence, and also there's some advanced functions that we want to you to be aware of. So I'll try to cover that first, so that when we discuss iteration 2, you are more comfortable with the concepts and the code that I'm able to demonstrate. Right? So that's the idea. Before we get into the lecture, some important announcements. First of all, about Lab 5, which is the lab that you are going to do this week. As per the timetable, it's supposed to be due this Friday. And the reason is because next week is Flexi Week, right? And we're not supposed to have any assessments due, right? But just to give you the benefit of the doubt, even if you submit by Monday next week, that should still be fine, right? So official due date is this Friday, but we are lenient. We know that you are used to the Monday deadline. So if you submit by Monday next week, still no penalty. So that's just something important for you to note. About iteration 2, like I said, the deadline is over now. Yesterday you must have provided the your team's information. Now this week is supposed to be demo week. So remember, attendance is compulsory. If you miss it, you get a 0, right? So there's a hard and fast rule about that. If there is some problem, right, for some reason you're not able to attend, please reach out to your tutors as soon as possible, and we'll see what would be the approach for that. But as far as we are concerned, you have to do the demos, and attendance is important for that. In terms of your marks, the auto marks will be released on Gitran on Friday. So by Friday night it should be there. Might be a bit late Friday night. So on Saturday morning when you check, definitely you should be able to see your results. And also we're doing some manual marking. Those grades will also be out by the end of this week. So yeah. Yes.
In terms of like the order model, you know how you said it's composed of the order tests that you guys have and the tests that we wrote? What's the formula for that?
So, I mean, for iteration 1, we try to look at your test cases, and as long as they are reasonable and basically cover most of the aspects, you do get most of the marks for that. Yeah. But we will provide your feedback on cases or things probably you haven't looked out for. Yeah. But as we go into iteration 2 and 3, right, things will become more stricter. So, yeah, just keep that in mind. Also, for iteration 2, there's some key requirements. Probably you may have not read this yet, so it's important to highlight that. There's a requirement somewhere down in one of the sections which says that you have to at least have 1 commit per week, right? And then failure to do so might result in penalties. So just keep that in mind. So going forward this week, next week, until iteration 2 is due, be consistent with your commits, right? That's the main. You can do more than 1, yeah.
Does that commit have to be related to iteration 2?
Yes. The other important thing to consider is we have been seeing even in the lectures a lot of code in JavaScript from this week onwards, we're going to transition to TypeScript, right? So maybe this week, even in the labs, your tutors might also help you out a little bit, transitioning between JavaScript to TypeScript. For those of you who are not familiar or are not too comfortable, we'll do the same in the lecture, so you'll see a combination of both, but moving forward in the coming weeks onwards, we'll only be using TypeScript. So just keep that in mind. So from now, when you write your code, try to use TypeScript as much as possible. Right? For iteration 2, definitely the submission has to follow follow TypeScript or use TypeScript. Right? Also, we want to ensure that your code is readable, right? So use the lint and TSC in your pipelines so that it can highlight errors for you. Also makes life easier for you and for us when we mark or view your code. Likewise for you when you are trying to debug things, right? So please do that. We'll also try to demonstrate that just in case if you're not too comfortable with that in the coming lectures. About next week, like I said, it's flexi week, so no lectures next week, right? So you get some time to at least reflect on your progress, take some time out, focus on yourself, right? There shouldn't be any content or assessment due next week as well. Like I said, Lab 5 official due date is this week, but just in case you need a little extra time, there's no harm submitting next week, Monday. Right? And finally, we already have started getting some feedback, some student concerns about group coordination, which is good, but like I said, these kind of issues will keep coming up throughout the semester. Core to software engineering is team management, right? That is something that have been emphasized in the course right from the beginning. There will be a lot of issues like team members will be dropping out. You'll have issues with conflicts happening within groups, uneven contribution by members. This is also something you might experience later on when you start working as well. How to handle that maybe at this moment is beyond your control. So please reach out to our tutors who have more experience in handling these kind of situations. The earlier you reach out, the faster we can help you out. Right? Also saves you a lot of stress. So don't leave these issues till the end of the semester. So these are the important announcements before we go on to the topic for today's lecture. Any questions? No? Okay. So let's look at a little bit more coding so that we can better understand iteration 2 as well. So what we're going to start off with is advanced functions. Now, implicitly, you have been using a lot of these functions already, right? We haven't highlighted that these are advanced functions. Some of you may have recognized it already. But in today's lecture, we try to show you what these functions and these new maybe symbols that are used in functions, shorthand notations, and so on, what they mean, why we use them, and how you can use it to your advantage. Right? So the objective is explore powerful ways higher level languages use functions. Right? You see a lot of languages have their own different syntax, and also for JavaScript it's no different. So we try to explore higher level languages, how we use higher level functions in JavaScript today. We look at the different structure and the syntax of the functions, like I said. In particular, we look at first class functions and higher order functions. And we'll try to understand the role and use of callbacks, which is something you'll probably be using in iteration 2 a lot. Right? So to start off with, you must have seen this code or code similar to this maybe over the last 5 weeks already. Right? So there are 3 equivalent ways in which you can code a simple sum function where you take 2 input values and you return the summation, or you add the two numbers and get the result out of from them. Now, if you run all these three, they will work fine without any errors, right? The first method, the one on the left, right, function syntax 1, is something you may have used in other programming languages as well. Now, this is the old school method where you use the keyword function, right? You provide a function name, the parameters, and state the return value. This is fine. If you look at method 2 and 3, right, this is slightly different because you see that the function is now assigned to a variable. And this is something that you must have seen a lot in JavaScript already, right? You treat functions like variables. In method 3 also, you'll see some additional notation, which is some additional, let's see the arrow operator on the right there, right? And you don't have to specifically use the keyword function in that case, right? So we try to understand what the reason for that is. All these three files pretty much written in JavaScript, right? If I convert them to TypeScript, I hope you're able to view that. You'll see the implementation is pretty much similar. Only thing new introduced here is the types, right? So for A, you have specified the type as number. We don't have a big list of different data types like C, Java, and other programming languages. We just use number for now. For A, number. For B, we use string and Boolean. So you see, it's pretty much the same, right? Now, just try to differentiate the three methods. If I just open the code, okay, you should be, as a software developer, aware of when to use which method, right? 2 and 3 pretty much are very similar. If you look at method 1, which is function syntax 1, right? So if I run this, sorry, I'm using the JS version. Let's use the TypeScript version, right? npm run tsx, and the name is function syntax 1. Something is playing up with my keyboard, right? And we get the result. Yeah, so it works fine. Now, when you write functions like this, these functions in this format, right? When they're not assigned to a variable, these are hoisted functions. That means when you call the function, you can actually call this function before it is defined, right? So in JavaScript, you must have seen that sometimes you can call the sum in this case, the sum function before the actual definition of the function, right? So the old school method, those functions are actually hoisted, right? So if I just save this, and if I run this again, right, still gives me the result. If I take you through the other method, right, so syntax 2, here, see, I'm trying to add 5 and 6, so I'll use syntax 2, works fine, but this one is not hoisted. Oops, sorry, did I use syntax 2? Okay, sorry. So, TypeScript, thank you. Right, so I get an error. Right, so there's a difference already that you have identified where you can use maybe the traditional method and where you can use the more modern method. Now, how does the first one actually work? What does hoisting actually mean in JavaScript? Well, definition-wise, I've already stated it, that even if the function is not defined before the call, it still works. Right? But how does it work? So what JavaScript actually does is before it runs the code, it scans through all the definitions or declarations of the functions. So if you're using method 1, it's very easily able to identify, right, that there's a function existing at the bottom of the page, right, and it recognizes that, and it's able to call that function even though it's not defined before the actual function call, right? So that's how it works. In here, I think it gets a bit confused, right? Even in method 3 as well. These are not hoisted, so if you run these, right, currently in this current state, it will run, right, because definition is first. And for this one, if I put the call before the definition, it gives an error, right? Because in this case, it's not able to detect that there's a function existing and that support is not provided for this modern approach to writing functions. So keep that in mind. What I'm trying to say is, of course, we recommend the more modern practices, but just be mindful how you call those functions, right? Definition before the call, right? Method 1, you don't have to worry whether you define it at the top of the code or at the bottom, right? You can call it from anywhere. So that is one slight difference in the way you are going to use functions. Right? There's another advantage you now see for method 3, right? So method 1, the advantage is it's hoisted, right? The other two have a disadvantage because those are not hoisted. But the other two are much more slimmer, right? Because what you can do for method 2 and 3 is, if it's only returning, let's say there's one line, right? You can actually compress the syntax for that. So if you look at, for example, this particular function, since it's just returning a plus b, you can just move it in the same line as the original assignment operator, right? So I'll just take you through that example here. Let's look at syntax 3, right? So this is the function. It's only returning one line of code. So I can get rid of these braces, move it to one line, and I can also get rid of the return statement, right? The reason I get these curly marks at the bottom is because some other files are using the similar function name or variable name. That's the reason. So you see, sorry, it's not hoisted. So definition should be made before you call that, and now you see it works, right? So a lot of time we see this shorthand notation for function. These are called error functions, right? So the things written in this way, we usually use the term error functions. Looks very complex, but it's exactly that same old implementation where you have changed it to the simplified syntax, right? What we'll do now is try to learn how we can, from method 1, convert functions to method 2 and 3. Right? Because your expectation for your project is most of you will try to use method 3, the more compact approach. Right? So here's another function, many string. Right? Let's not worry too much about the content of it. Right? What it basically does is you call that function and 5 times, because it's using a looping structure, prints hello. Right? Now there's another function using the arrow function notation which does the same thing. Right? looks more fancy, slightly more complex, but it's the same function, right? So all that has happened is if you look at many string, right? So I'll just many string 1.ts, right? So all it's doing is displaying hello 5 times. How can I make it more advanced and compact? First of all, I can use const here. So I can use the assignment operator and then move function keyword here, right? So just swap them around. So now it looks like this. If I run this will still work, right? Prints hello 5 times. Now what I can do is instead of the function keyword, right, I can just put up the arrow operator. So the TypeScript compiler can know that now that's a function and is assigned to a variable, right? Run still works, right? Looks more compact and advanced, right? But does the same tasks. And all this code is actually available for you to try. I guess with more practice, you'll get more proficient with it. And what you can do as well is your code from iteration 1, if it's using the standard function notations, can be converted to slightly more advanced functions, right? You can, before jumping to these fully advanced where you use the arrow notation, you can also have that intermediate step, right? Where you just assign it to a variable and then you see that the function keyword still exists. And then in the third step, you can just move to the more advanced notations for your functions. Right? So when we convert from a normal function like this to a function which gets assigned to a variable, we call this in JavaScript first class functions, right? What it means is that now our functions can perform like variables in the sense that it can be treated like variables. It stores some kind of functionality. It can be passed as parameters, right? And it can be retained by other functions. So now that just like variables can store values, it can be passed as parameters to other functions. It can retain values. Same as that, as soon as you assign your function to a variable, your function becomes a first class function. That particular variable, right, can now be treated in the same way that you treat a variable. Yeah. Yeah. Any questions? I know for some of you it might be just a slow, I'm going a bit slowly, but for some of you things are new, so probably you need me to go and pause in certain steps. So yeah.
We define function return type in like the arrow method.
Return type.
Yeah, so it's returning a string, right? So do we need to define that in TypeScript?
Yeah. I think currently we are just handling the parameters. Yeah. So you don't have to worry about the return. Yeah. Okay, so now let's look at some other first-class functions, right? So you see, we have a new type created called formatter, right? And then it's a function that accepts a string, right, and returns a string, right? And we have some other functions which are assigned to a variable. All of them seem to follow the same template. Then we have the say hi function, which takes the name and then calls some other function, right, which has basically a template similar to that. So at the moment, it looks very confusing for some of you. So what we'll do is we'll go back 2 steps to how these functions are originally defined, right? And then from there, we will come to what this current smart looking output looks like, right? So let me just grab the name, FCF. Okay, so this is basically the starting point of it all. Right. So we have a function called brackets. What it does is it accepts a string, right, and then returns that same string, but enclosed in open and close brackets, right? There's a lowercase function which accepts an input of type string, right, and converts that string to lowercase, right? Now we have declared a type, right, because we want to pass a function as a parameter, and anytime we send a parameter using TypeScript, we have to define the type of that variable, right? So in this case, the type is actually a function, so we have to actually define a type. Just like if you want to create a new object like type student, right? We do something like this. Right? Are you familiar with this syntax? Right? Or structure when you create your own custom structure, right? So it's the same thing. What we are saying is there will be a function, right? And then it accepts a string as an input, and it's going to return a string as output as well, as the return type. So it's pretty much the same thing. Custom definition of an object, in this case, which is a function, and you'll see this template is adapted by these 2 functions. So when we call these functions or pass them as parameters for their type, we can actually use this as the type, isn't it? Because it uses the same template. It sends a string as an input parameter and then returns a string, right? So pretty much these 2 functions follow the same template. So you'll notice now in the format names function, right, which is our own traditional function, with the function keyword, it takes this array of names of the 3 lecturers we have in this course, and then it will take also as a parameter the variable or whatever is format, and the type is function, right? So it will take in a function as a second parameter, which is basically a function that's complying to this particular format. Now what it will does is just creates an empty list, goes through each of these elements in this list. So for example, picks Henry first and sends Henry to format, right? Then sends Shavin to format, then sends Yushao to format, right? Now you'll notice that when we call this function, first, when we call format names, the function we send as the parameter is brackets, right? So let me just comment this here. Right? So it takes the names array, Henry, Shavin, and Yushao, and the function it's sending is brackets. So what these function format names will do is take out Henry and send it to brackets, right? And what brackets will do is enclose Henry in double brackets, right? And once you get the result, you push it back into the new list. And then you send Shavin, you send Yushao. Now let's try to save that and just quickly run FCF format loop.ts. Right? So that's what it has done. Right? So it's taken that list and then just enclosed each element or each person's name in brackets. And remember, all these individually, when they were returned, was pushed into the new list. We return the new list. The new list gets assigned to new names, and then we just outputting the list again. So the entire list is displayed again, but this time formatted according to the function that was called, in this case, brackets. Now if I do the second one, I think it's obvious what will happen. This time, the function we are sending in the second parameter is lowercase. So what happens is this function takes in the whole array, pops each item out, Henry, and then the function it calls, format is actually lowercase, right? So it calls this function lowercase, and then sends Henry, then Shavin, then Yushao. When it gets the result, it just pushes it into a new list which was initially empty, returns this list, we are displaying that list. Right? So now the names are in lowercase. Right. Now this is actually comprehensible, right? We see, oh, makes sense. For anyone, this is not making sense? Right. For some of you, maybe this is not making sense, right? Let's see. This code, right? Brackets, let's not worry about full stop. Let's say we have lowercase, right? Maybe it's too compact, so affects your readability. But how did we reach this state, right? This is how we went there, right? So first one is straightforward. Second function, we can put const because we want to assign it to a variable, and we can move function here, right? Now that will still work. I can shorten it further, get rid of function, and then put the arrow operator, right? Now it's just returning one line of code. I can get rid of these curly braces, and I can get rid of this return statement, and there I go, right? A compact version of brackets. Can do the same for this one, lowercase. Const, and move function here. Now this is method 2, right? Assigned to a variable, but still retain some of this initial syntax, right? Has the keyword function and so on. Now going on to more advanced syntax, which is arrow functions. Right. Right, so that's more compact now. Right. I can improve this a little bit further, this one as well. I can do const, and then this is currently method 2, right, where it gets assigned. So it's a first class function already now. Now I'll convert it into an arrow function. Because there are so many lines of code for this one, right, I'm not going to jump to the oversimplification straight away, right? It's something later on during the lecture we'll discuss. But for now, this is all in method 3. and slightly more compact, right? Now, not only it becomes a little bit easier once you become a confident programmer to read and understand what these functions are doing. It also makes it easier to reuse these functions, call them over multiple places easily. So you know you just have to call brackets and then just pass a string. It will include the brackets wherever you are in your program. Only thing is they are not hoisted, so they have to be defined right at the top or included from a file right at the beginning. So that's the benefit. What's the other benefit of using method 3? Compacting all these functions into very few characters or very small sizes. Less lines of code, and the benefit of that is easier to debug. I mean, initially for some of you it will increase the complexity of debugging. Right? Remember, you are building something for the web, right? So the amount of data that travels between client and server, right? Sometimes you have to import libraries and packages, right? You want to minimize on the bandwidth utilization as well, right? You want the websites to load faster. If you have some interactivity functions for your user interface implemented or has to be downloaded from the server or from some CDN, if it is compact like this, they'll run much more faster, right? They'll load much more faster on your web pages, right? So that's another reason why you want to adopt this style of programming going forward. Maybe not immediately, not today, but over the next few days and weeks. Okay, there are more examples to take you through this, right? Okay. The other concept that is there is anonymous functions. So sometimes you may define a function, but you'll only use it once. Right? So how can you save space and make your code more compact in that case? Right? So instead of using those additional keywords and declarations and so on, what I can do is, for example, if lowercase is something like this, right? Let me just see the example so that it can resemble what we have on the screen as well, so people online can follow as well. So format loop new. Yeah, I think we can just apply that to our old example as well. Sorry, where's the old example gone? Yeah, so this is the one we identified, right? So we simplified, and then just to check that it's running properly, right? So we got the lowercase, remember? So instead of writing lowercase here and having it defined as a variable here, this is the exact implementation, right? Since we call that function once, we directly embed that function, get rid of that, right? So we save one line of code, right? And in a state of things where you write millions of lines of code, right? It can make a lot of difference in terms of how systems and other functions are going to utilize those savings that you have implemented, right? So you see, now I don't have a function lowercase, just no function name. This is anonymous function. Run my code, and it still works. Right? Likewise, I don't need to declare or have a function brackets. I can make it anonymous because I'm using it once, and in here for brackets, I can just pass in the function definition directly, right? And now I have got rid of those two lines or implementation of those functions. And those functions directly themselves, the definition itself, gets sent as parameters, right? And if I run, right, so both brackets and lowercase both work the same, right? So you can totally get rid of the function implementation and pass the function directly in the function call itself. Right? So you will see a lot of examples of those as well. So this concept is actually called anonymous function. So anyone reading their code basically has no clue that there's a function called brackets used anywhere or a function called lowercase, right? Unless you kind of sense that, okay, this is doing something lowercase or returning something lowercase, these functions operate anonymously and serve the same purpose. There's a question, what is formatter that short for? Yeah, so it's basically just a keyword, just like we say type student, type player, type tree, and then type car. So that variable name we have, this formatter is just a variable name, right? You can use anything else in place of that. As long as it's not a JavaScript keyword, you are safe with using any other name for that. Right? Because all these functions use the similar template, the brackets, the two lower, maybe two upper or something. They do some kind of formatting to the string, right, and returns the output. The generic name that was used for that template of functions was formatter, right? FMTR, right? Just a variable name or type name for a function. So in summary, what we have been looking at is first-class functions, where functions can be treated like variables, right? You assign it to a variable. Now to come to that stage, from your traditional style of coding, you can convert it where you assign it to a variable, or you can go to more advanced form of coding where you can use the arrow operators and then use that function as parameters for other functions, or call that function or return that function just like you would use a variable, right? So that's what first-class functions are. So anytime you transition from the traditional style to this modern style, you have created a first-class function. And the benefits we have already discussed, very concise, makes the code quite readable, maybe not initially, but once you get more comfortable of the notations, it makes it more readable. You can also support anonymous functions this way, right? Because of first-class functions. One of functions sometimes you create and never use it again. You can just directly create them in the function call. Just put the definition there, right? And also, these first-class functions are important because they can be used for callbacks, which we'll discuss shortly. For higher order functions, where these are can be input to a function or can be a return type for a function, or it can be something that can be used on in functional programming, right? So in functional programming, what you do is you build a big program based on a combination of small functions put or stacked on top of each other. So in this case, your first class function becomes much more easier in terms of helping you out with building such applications. Right, so we'll take a break and we'll see some examples of this in action shortly. Right, so 2 minutes break. This is not the mid-lecture break, but just a 2 minute break just for you to digest what I have been talking about and then ask any questions. You'll be writing a lot of functions in iteration 2. That's why a lot of emphasis has been made on the right coding style for functions and trying to understand for some of you what those arrow operators meant. It's not something too complex, it just refers to some kind of function, replaces the function keyword, appears in a strange place in the code, but that's what it pretty much is. Any questions? Remember, the code is on the course website. If you want to also try it out while I'm demonstrating, feel free to do that as well. Okay, another kind of another kind of advanced function that we're going to look at is the map, reduce, and filter function. These are quite advanced functions which basically act on arrays, right? And it helps us in a lot of iterative tasks. So if you plan to use JavaScript a lot, if you happen to end up as a web developer designing the back end or front end, a lot of times you will, in combination with other languages, might require JavaScript knowledge as well. So you'll find that you will encounter map, reduce, and filter functions a lot. And basically it helps you do a lot of iterative tasks, right, much more easily. And they are basically based on the concept of first class function and anonymous functions, which we have just discussed. So the map function on array basically modifies an array, right? So you have an array. What you do is, if you want to transform it into another array which is the same size, but maybe with different elements. For example, if I have all your marks, right, 600 students, your marks in an array, and I want to transform that into grades, right? So for the same 600 students, their marks, if I want another array with grades, the function that can help me with that is the map function. Filter. This filter function basically retains a subset of an array, right? So it might provide you the entire array or elements that meet the a certain criteria. For example, if I want to know how many students got HD, right? Then I would use the filter function, and then it will just list the students from the array which gave me a HD, right? Or have scored or earned a HD. Remember, in map and filter both, the return type is still an array, right? However, in the last one, which is the reduce function, this provides a summary of an array. So if you have an array of student marks, 600 students and their marks, and if I use the reduce function, it will reduce that entire 600 marks to maybe one value, right? And that could be, for example, the average mark, right? So that's one way of looking at it. Or it can just sum it together and, for example, if you have a team of cricket players and they scored X number of runs during the year, then you can say the team scored and you sum all the runs everyone has scored, so all the data from the array, and you get one value that the team in total in the year 2025 has scored this many runs, right? Maybe 5,000 runs, something like that. So it gives you one value as a, returns one value, which basically is a summary of maybe processing that entire array. So map and filter returns an array as the output, but reduce gives you a value. Right. So looking specifically at mapping, you can see that map takes an array of size n and produces a new array as an output of size n. Right? So the array size doesn't change, it just modifies each element based on whatever the function that you have called and what action it has taken on the elements. Right? So just the elements have been modified. So this is a example of using map, right? So let me open up map old.ts. Right? A list of tutors, their names, right? And what I do is call the map function on the tutors, right? And for each input or each element in the array, for example, Simon goes through the processing chain first, and we return the uppercase of the name Simon or the string Simon, right? What map does is, it's more like a conveyor belt. You put an array in the front, it iterates through, takes one element out, goes through what the function does on that element, and then takes the next element, and in the end, it repackages the whole array again, the same size, but with the modified values, right? So that's how it works. And if I run that, you'll see npm run tsx, and then this is map. Right? And we see the same array, but this time the elements have changed to capital letters. I could have passed an array of numbers, and then the function would have maybe just converted them to pass fail status codes, right? Or grades. And then I would have had the same array, but against, for each element, the corresponding index for that student number or mark, I would have got maybe status, grade status, or a grade letter or something, right? So that's what mapping actually does. Now, just using our knowledge, you see that same yeah, you can see this same thing, right? Which is in a classic style here, right? Using the modern style where the function is extracted, and then this is a case of anonymous function. Here the function is extracted and assigned to a variable, and then what we do is when we call or use the map function, we just call that function, right? Shout. And what it does is, as I said, each element from the tutors array gets actioned on by that function, right? And in the end, package them back together, and you get an array with the new elements. Right? Same as or similar to map, right? We'll skip reduce, we'll go to filter first, which is because there are a lot of similarity there. In filter, the values are not changed, but the array becomes smaller. So normally, based on some criteria, what we do is we filter out some elements. Right? Just like you go to a website, let's say you go to Harvey Norman or JB Wi-Fi website, you go to Apple devices, and you are set some filters. So the array of or listing of all the products gets filtered only specific to that criteria that you have set. So that's what filter does as well in the array context. So you have a list of names and marks, right, of students, and you see the criteria set here is mark is greater than 50, and you'll only get students with marks greater than 50, right? Similar to in this case here, you have an array of just plain values, which are assumed to be marks in this case, and you have a function which is a first class function, right, assigned to a variable, and then that function is called by the filter function. Right? Now in this case, each pass is a first class function, filter is a higher order function, because it's a function that is having a parameter which is a function, right? Right. Now reduce basically, like I said, takes the array and then does some kind of processing and turns the entire array into some atomic value. So for example, if you have a lot of numbers, you can find the average or the median or the summation of everything. So the entire thing is represented as one single value. Right, so this is an example of reduce where we have an array of student marks, right, which basically have a structure, name and mark. And what we do is we iterate through the array and add the values. This is the classic style. You would add all the marks to find that atomic value of total marks in this case. And this is the modern way that we are learning in this course, where you put the function, assign it to a variable, and then call the reduce function, and then pass that particular function as a parameter. Now, you see a few additional things passed as a parameter, so I will discuss this code now, and then we'll take a short break, right? So it's reduce.ts. I'll just clear this. Right, so let's see what this function does. Right? So we have a list of student marks. Right? So in the student structure, we have name and their mark. There's a function sum, which takes a number, which is the previous mark, right, or the previous tally, and then for each student that is passed through by reduce, right, it just adds to that tally. Right? It's like if you are in a match, like a cricket match, you have 11 players who are batting. I have a tally and I'll say start from 0. Each player gets out, come Sauva, and I add his runs to my team tally. Right? So someone scored 50, then next player comes in, maybe gets 30, so I add another 30. So that's what sum is doing, right? I have a previous value, which I will keep as the initial tally that I have, and each student that comes in, their mark value gets added to the bucket or the tally that I have, right? Now, what happens is, when we call that function, we use the reduce function here. So on the student array, we call the reduce function, just like map, filter. What reduce does is iterates through every element, right? So what it does is it calls the function sum. 0 is the initial value so the next parameter for reduce is always the initialization value, which is previous, right? So that's 0. And then because we call that function on this particular array, so each element of that array is then passed through as the parameter here, right? So the first element, their mark, 55, is added to the initial value 0. And then second element, 43, because we had 55 as the tally already, gets added to the previous value of 55. So that becomes 98. And then the third student, fourth student, and so on. Now when we run this, use.ts, right? We get the final tally of 155. Okay. Now what we'll do is we'll take a break now so that you can reflect on what we just discussed, and then we'll look at a realistic example, right? So when you do your online shopping, right, you start with a cart, shopping cart. So we'll use a realistic example. Some of you provided feedback that we can move away from these simple examples to something more relevant that we use every day. So we'll use a shopping cart example to see how map, reduce, and filter works when you are shopping online, right? So, yeah, let's take a break for 5 minutes, right? 6 minutes. So we'll start at 3:15, and then we'll try to round up advanced functions. Okay, in the meantime, I'll just look at some of the questions in the chat. So there's a question about converting input to lowercase. If you could just clarify it a bit more, I'll be able to answer that towards the end of the lecture. Yeah.
So like when we are using the third method to write functions, right? So how do we export those functions? Because like right now we're using the function name, right?
Unless, yeah, as long as it's not anonymous,
Yeah.
then you can use that variable name which holds the function.
So we export the variable.
Oh, yeah,
name,
yeah, yeah, which kind of holds the function itself, yeah.
Okay.
Yeah.
And another quick question. You use some sort of dollar and those curly braces. Right?
Yeah.
What is that?
Those are actually templates to embed variables. So we use the what do you call it? Um, the left code this that operator. So what we do is if you want to embed or some values within the so that variable name or even sometimes some computation in there, if you use $sign calibraces, then it will interpret it and use that value there, right? Otherwise you'll have to do like traditionally plus and then sep at the end, right? So instead of that long way, it's a shorter way, just embed it in with. Two more minutes before we get started. In the meantime, I know that in iteration 2, a lot of you might experience some issues with maybe importing, doing merge requests, merging requests with your code and so on. Remember, there's a lot of help sessions running, a lot of mini help sessions running. That means at the end of every tutorial, there's always a 15-20 minute block, sometimes more, which you can attend to get some quick feedback from tutors on your code and things like that. Because sometimes it's hard to guide you or meet you face to face in person to help debug some of your issues, right? And I know you can post some of those issues on the forum, but without a lot of context, it becomes hard to also debug those errors. So if you want guidance, I'm not saying that the tutors will solve the problem for you, but they will point you in the right direction, right? They'll help you maybe to interpret some of those error codes, some of those messages, and eventually at least get out of that stressful situation, because it can delay your project, right? So far, our online help sessions, even face-to-face help sessions, are not fully utilized. Likewise, those mini help sessions, that is some time slots which are available at the end of every tutorial. Yeah, but you're also free to ask us via forum or email as well. We'll try to help you where possible. Okay, sometimes answering those questions might require a little bit of research on our part as well, because some of those issues might be something that we don't encounter every day. So just keep that in mind also. Okay, so let's look at the shopping example. Maybe it may make more sense of how MapReduce works, right? So here's a simple example. Suppose you do some online shopping. I've identified some very basic products: apple, chips, milk, and chocolate. For each item, there's a price value, there's a quantity, and then we know very common these days is the discount. So some items are on discount, so the status is true, others set to false. It's basically stored in the cart array. So if I just want to see my shopping list, right? At the moment, I'm using my terminal window. This is something you are frequently going to be using in your browser in future when you build applications. So let's see what the shopping list looks like in the terminal, right? So I just have to run this, which basically means npm run tsx online shopping. So this is the old version because it uses those traditional style of coding, right? So pretty straightforward. Whenever you view your cart, shopping cart, this is what you see. Now, a very common application of map function is when you want to, for example, see the line totals, right? Line total means you want to know how much are you spending on apples, how much on chips, how much on milk, how much on chocolate, right? So normally when you get a shopping cart summary, you just get the product, maybe the line total for that product, apples and so on. And then if it's a discount, I think most of the organizations put some asterisk symbol or things like that on the receipt. But those are the key information. So what we'll try to show is we'll try to map this array, transform this array. So instead of showing price and quantity, we want to see the total for that product, right? So just the line totals. Apple, line total is $10 and discount status is true. Now to do that, what we'll do is from this array, each element that gets passed through, we'll take the name of the item because that's important in your cart, and then we'll have a total column which will have price times quantity. So the product.price, product.quantity, and then product.discount, which is the third field. Now what I'll do is use the map function and call the calculate item function. And what map does is, like I said, on a conveyor belt, there's your array of products. It takes the Apple element, right, that entire structure for Apple, puts it on the conveyor belt. Calculate item is the function that actually does some computation based on those guidelines and just waits for the array to actually, all the elements to finish. So calculate for Apple, calculate for chips, then milk, then chocolate, packaged together as an array, and that is what map will actually return, right? An array which has item totals. What I'll do next is console.log item totals, right? Right. So now my output line totals look like this. So this is how I've used the map function to retain the same array, right? Only thing is the elements have changed, right? Now the next thing in the shopping cart is after you see the line totals, you start making some, maybe questioning some of your buying decisions, right? You say, okay, let me buy only items on discount because other items are just standard price. I can buy them anytime I want, right? So you want to take advantage of the discount. So what you can do next maybe is to filter out items that are not in discount or not on discount, right? So how do you find out if an item is on discount or not? So for each element that you get, you look at the discount attribute, and if it's true, we know we keep it, otherwise we discard it. So we return if it meets the triple equality operator true. And basically that's what filter does, right? When you call filter on your conveyor belt, sends all these items, right? Item totals, which is this particular array now, and just looks at the function looks at the discount field or attribute. If it's discounted, that means it returns true, keep that. If it's false, discard that item from the array. So at the end, you have an array packaged with only items that are on discount. Right, so I'll save that. Just clean up the screen a little bit, and I run that. Right? So now I only see 2 items in my shopping cart, which are actually discounted items. And the last one is reduce, where you want to do a total tally. That means what's your total purchase cost, right? So that's what reduce is doing. Let's get rid of this. So only the discounted items I want to use, right? Just uncomment all these. So I'm using the reduce function, right? And I'm calling the calculate total function. So what it does is, it starts with a starting value, 0. That's my total purchase cost at the moment. And each product I get on the conveyor belt, right? The function basically takes out its price, right? The total, and then adds it to sum, right? Product waits on the conveyor belt towards the other side now. So all the items when they pass through, it just retains one single value, which is the total cost, right? And then I run this, and then my total bill is only $13, right? Which is basically the total for apple and milk. Right? Now, anyone has any questions? Right? A very simplistic example, a realistic example, but of some of these complex functions that we have learned. Now you'll notice that we started with a total of 0, right? Some of you, when you do shopping, you may have some rewards dollars in your account, right? So in that case, it will start with a cost of not 0 to you. Maybe you have maybe $5 worth of rewards. So it can start with a tally of -5. So the organization is owing you $5 when you start shopping because you have $5 maybe rewards points or something, some kind of loyalty program. And then in that case, you start with -5. Each item total gets added to the sum. And you'll see that in that case, right, your bill is only $8. Right? So that's the importance of having that parameter, which is the initialization or starting value that we set in the reduce function. And that's a mandatory parameter that has to be sent. So that's a example of map, reduce, and filter functions, right? And it uses a lot of things that we have already learned today and in the past few days. Now, there are a lot of functions here. Remember, these are traditional functions. We could improve that. We can change it to const function this. So this is now method 2, where function, this is a first class function where the function is assigned to a variable. Further improved it into an arrow function. There are multiple lines there, so we'll just keep it here. There's ways which we can shorten that even further, but we'll not go into that detail straight away today, right? Likewise, you can apply it to all the other functions as well. So you notice that there's another version of online shopping which has that simplified format. Now, once you actually reduce that function, let's say to this, right? You can straight away just copy that and paste it here in map, right? And now that becomes your anonymous function. So you don't have to have a function. That is useful if you are using that calculate items function only if you use it once, right? So you can create an anonymous function there. And that will also run as well, right? So there's the code for you to try out. And with that, we'll just round up advanced functions for now. Right? Let's see, there's a few slides here, what they say. Just summarizing, higher order functions are essentially functions that return functions. Think of them as mini functions. Right? So there's another example where you, from a normal function, you can convert it to an arrow function. Right? And that function gets assigned to a variable, and then you can actually call that function. Right? Right? And the main reason we have higher order function is we want to have code reuse, flexibility, and it's more expressive, and like it's more cleaner and modular as well, right? So those are some of the reasons we try to compress those functions. And with that, I think we have reached the end of the first part. There's a few more slides to cover. Excuse me. Okay, now this is basically one of the core concepts in your iteration 2, and that is persistence. Right? What we'll try to understand is the definition of persistence. Anyone knows what is persistence? And why is it important? Something to do with the data. Have you seen me rerunning the server many times in the past few lectures? Because after you delete some of those books from the book list, then there's no more books in the server, right? And we try to retrieve books, it's always empty. So when you restart, right, there's no, there's no initial state. Right? So persistent basically means is you want to provide some kind of permanency to the data that you have, right? At the moment, all the data that you generate in your HTTP server currently from the examples we are seeing is temporary, right? We insert a book, we delete a book, we update a book. As soon as we stop the server, the data is gone. Now in real life, that's not useful at all, right? If you go to a website, you create an account, and then you log off, or the server goes through maintenance, and then you have to go again to the website, you have to create an account again. That's a very painful experience, isn't it? So you want the data to persist or to be stored somewhere. And in the context of this course, we want the data to be stored on a disk. Now, for your iteration 2, when you do authentication of user, when user logs in, right, and then logs off after creating an account, you want that account to be there all the time, right? If you add a quiz item or create some other objects or structures in your program, you want them to be safe somewhere, right? You don't want to each time log off and log in, you have to redo the same things again and again. So for that reason, persistence is important, and that's what we're going to focus on. Now, in real life, persistence is enforced through databases. We won't go into databases because that's a subject, a big course on its own, but we try to use file storage, just simple files to store some of the data so that our server can still function like a normal server, right? We all agree that we have data generated by every software, and it's very critical. Even in your programs that you are writing, you have variables. Those are data, right? Basically runtime information that is generated. But that's not the type of data that we are mostly worried about, right? We are worried about certain functionalities, records that are important. The variables that you generate or create, basically when the program stops, those data actually disappear from memory. And sometimes those are not that important anyway. But what persistence does is it allows information to be retained even after the program actually stops running. So if you create some entries, some books, let's say, if someone else logs in to the library website, they should be able to see that same book or the information, right? So it allows for consistency and reliability of the service. Later on, if you want to analyze some trend or usage of information that you have created, if you don't have the data saved somewhere, there's no analysis that can be performed, right? So it also supports data analytics as well, and basically is central for real world application, right? So when you enroll at a course here at UNSW, that record has to be persistent, has to be permanent somewhere in the entry. Otherwise, every day you enter through the gate, you have to enroll in COMP1531 again, right? And that's not how things should be. There's another concept called big data that is like the buzzword now on the internet, and people are talking about it. We're not going to focus on that big data, but on a smaller scale data that are useful for applications, right? So just this course will not address big data. Now if you look at an application, a program that you are designing, it has multiple layers, right? It has the interface layer, where the user interacts. It has buttons and different objects. It has the business logic, so the actual processing or execution of certain functions and code. It has a services layer where it integrates with other services, maybe to support login or to do some kind of payments. And then right at the bottom is usually the data layer of any application, which stores all the persistent data. And that's where we're going to focus on. So if you build an application today, a web application, it will have most of these layers, right? Including a data layer. Now, in your context, and from examples from the lecture, your interface layer would basically have endpoints, right? So it will just allow you an opportunity to interact or make requests. The business logic is the actual function, like your auth function, and what it does, compares passwords and things like that, right? Here it's a get user function that extracts some information, and the implementation of that logic is actually the business logic layer, right? Services layer in a website is usually when your server or your software interacts with some external service. For example, for authentication, it might use Okta or some kind of verification. It can use different websites for payment features, right? So those are service layer. And then the data layer is basically databases, which basically run on queries. In our case, it will be a file. It will be a JSON file, which will use a library in Node.js to read and write from and to. Now, the term for data layer is synonymous to databases. So basically when you talk about databases, there are three types, right? Or three common ways that it stores data. One is in the memory, just like we have been doing in our application so far. Everything array structure is basically created in the memory, records are entered, deleted, and so on. As soon as we stop, it gets deleted, right? The second is what we're going to use in iteration 2 and 3, using a file structure. Just like Word, PowerPoint, and other files, we'll use a JSON file in our case. And the third is a more powerful way, which is a more organized way of storing information, right? Which is basically using a relational database or no SQL database, which basically means it has some SQL elements and some other elements too. So it doesn't mean no SQL, it is actually not only SQL, right? So that's how you interpret that. Now, if you want to learn about databases in detail, there's a course that you can take later on, right? Like I said, we have been handling data, variables in memories, in the registers, when we are pushing, popping items of arrays and things like that. But that's not the type of data that we want to store permanently. Maybe the type of data we are talking about is maybe user credentials and some other information, right? How can we actually do that in our project? I think that's something that's more important as part of iteration 2. So rather than making a database, an SQL database, we'll just use a JSON file to store some key records. And to do this, we will start with some basic functionality. We'll learn how to load data from the file and how to save data to a file. Have you tried this already in the labs? No? Okay, maybe we could do this together. Right, so I'll just open the books library. Right, so this is the books library. I'll just use the work in progress file. Right, so this is the same books server that we have been using for a while. I've already added 2 books. This is not coming from a file. It's just gonna load up in the memory, in the array, when the server is started. So what I'll do is just run this. Okay. So far this is running. I'll just use a web client today, just for easy verification. We can use the terminal curl scripts as well. Clear some history from maybe the last lecture. Just double checking, right? So this time I just changed the port to 3001. You can use whichever port like I said. And let's just use the get function, right? So currently running locally, not reading any data from the file, and it has 2 items there. We know that we can perform the put, delete, and post function, right, on this as well, and they should work fine because we tested it a few times already last week. Now let's see how we can, instead of doing this in line with our project, do the same thing. Let me just stop it, sorry. By reading it from a file, right? So first of all, we have to install the file system package, which in my case, because I tested it before the lecture, is already installed, right? So it's a simple package which we just have to import. We call it FS, right? Now, what do we need to do next? Because we're going to read from a file, right? What I've done is just created a books.json, and let me just put some information in that file already, right? So that we can start by reading rather than starting with a blank file totally, right? Now these are basically the 2 elements from the array. So what it means now is I won't need these 2. So I will comment them out at some stage, right? For now, I'll just leave that out because I don't need the in-memory database anymore. Sorry, I put here from, giving that red line. Now I have to reference the location of that library. So for that, const, this is the file, equals, and then I just have to put the location, right? Books dot JSON. Right. Now here, because I'll be using books, because I've commented this, I'll be using this array again and again let me just, for simplicity, just keep an empty array so that my code doesn't break. Right? It will be populated from the JSON file. Right? Now, when I try to read a book, right, then my books will be equal to, anyone knows the function to read a book using the file system library? Right? There's two ways to read a file. You can go to the API docs. One is the read file, and there's a read file sync. Anyone knows the difference? One is asynchronous, one is synchronous. We want to be synchronous today. The reason is because when we are writing to a file or reading from a file, we don't want the code to still be running because there can be a mismatch. Sometimes certain writing and reading functions can take a long time. It won't happen maybe for a short application, but for a bigger application, it can be problematic. So we try to sync it. So what will happen is when the code comes to that particular line, it will read the file before it tries to go to the next line of code, right? Because a lot of JavaScript code also is asynchronous. So it means it will keep loading and jumping to the next section. And sometimes you might have some unexpected errors as well. Right? So what we're trying to read is, first of all, we have to specify the path. So we have books as the path. Right? The next thing is, which is optional but is mandatory, is the encoding. So because it's a JSON file, we have to use the appropriate encoding for that file, and the encoding for that is UTF-8. Right? Otherwise, it will read it as a binary file, and if you have opened a binary file, you'll see some weird characters showing, right? Which is not maybe interpretable or readable by us, right? So we don't want that to happen. So that's when we do that. There's another get function that we have. Okay, here. Because it needs to know what the book is, right? The reason I have put it here as well is maybe before this get function, if someone jumps to this particular function, then there will be a mismatch in terms of the results. Okay, so let's see. Okay, Control S. Is this the spelling of the file, is it? Oh. No. Books file. Oh, sorry. This is fine. So JSON, this is my /books.json. This is empty array, books. We have made books file. Okay, let's. No such file or directory. npm. this file does exist. This shouldn't be the problem. Mm-hmm. Anyone can figure out where I might have made the mistake? Okay, let me just uncomment and just.
Read file sync for another one. It's going to be books file and then page for books.
Uh,
Right, like the second function. Second, yeah, that one. Books file.
oh yeah, here. So yeah. So that's a problem. This is books, this is books. Okay, let me just get rid of this for now. No. Okay, let me go to my backup again. Let's go here, back to the original state. Let's see if this works. Oh. TSX. Okay, now this seems to be playing up. Let me just try some other code. Let's see FCF. In the right directory. No such file or directory. npm node modules.bin. Okay, this is strange. Okay. Just let me give a try again, and if that doesn't work, we'll try to conclude here, and I'll probably just include an additional video at the end. CD code. Okay, in the meantime, I'll try to answer some of the question. Kenneth asked, data stored is not lost after process ends. Yeah, if it's stored to a file or a database, in our case for iteration 2, it shouldn't be lost. Does the book course cover cookies? No, we don't cover cookies at all. Let me just do one last try. Books. Yeah, it seems like, yeah.
Have you done npm?
Huh?
Have you installed JSON?
You mean, yeah, I have installed it already.
It says that COMP1531.
Yeah, I mean, it was running all this while with all the demonstrations, right? So I think it just,
I think the point is just run npmi again.
okay. NPM. Yeah, I think probably I have to install TSX again, probably just to fix it. So I won't take too much of your time now. I think we're already over time. So we'll round up here. Expect a small video in addition to the lecture recording available where we'll be able to actually read the data from this file, which will be this books.json, which has a predefined listing of books. And then using that, we'll try to update, delete, and also insert more records, and also we'll try to write that back to a file. But if things work on your end, the solution itself is available. There's booklib.persistent, where you'll notice that I have imported that function library. I've declared the location or the path of the book, and basically when reading, using my get function, so I've created a function called read books, but I'll provide you a simpler solution in the video. Okay, so sorry about the technical issue. We'll see you after on Thursday. Yeah.
I got that issue fixed. I don't know what it was, but all I had to do was go into another branch and then do git reset.
Reset
And that
it.
just fixed it.
So maybe
I don't know what it was.
so
I
strange.
think it was one of like group members, like they merged in something, and then someone else made a bunch of commits, but then didn't merge.
That's what I was thinking from the
Yeah.
message, but it's still, yeah.
Yeah.
Even I'm confused what happened here, like the TSX was working and then,
I had a similar issue. It might be just a typo.
huh,
Like it might just be the directory
Huh.
that you got it from. Like that's what I have.
anyways, okay, see ya. Yeah.
Are we gonna do like the persistent stuff in this iteration of the project or?
These ones. Yeah, I mean,
I couldn't find anything on the some of it.
okay. Okay, I'll clarify that on Thursday. I'll just revisit the requirement again because we don't want you to, handle those. I mean, every time restart server again when you test your program and so on. Yeah. So that's the main benefit of persistent. Yeah.
Thank you.
Thank you. Yeah.